Okay, welcome everybody. My name is Rob Schultz. I teach AP Computer Science A at Bellbrook High School in Bellbrook, Ohio, and we're now moving into topic 1.4, compound assignment operators for our AP daily video series. This is video number 1 for topic 1.4, and we're going to continue to build off of what we did in 1.3. In topic 1.3, we talked about the 5 basic arithmetic operators, and we talked about the assignment operator. In this video, we're going to look specifically at the compound assignment operators. We're going to look at how we can take the 5 basic arithmetic operators and combine them with the assignment operator as kind of like a little shortcut. Okay, so the specific takeaways, we're going to continue with kind of this same learning objective that we've worked with in the past. We want to continue to evaluate what's being stored in a variable as a result of an expression with an assignment statement. But now we're going to look specifically at the compound assignment operators. And notice that when you think back about the 5 arithmetic operators, addition, subtraction, multiplication, division, and modulus, we now have a compound assignment operator that kind of partners with each one of those. So really what I'm doing is I'm taking my basic arithmetic operators and I'm kind of partnering them with the assignment operator to create these brand new compound assignment operators. Okay, so we'll talk in a little more detail about what each of these does. Okay, so let's start with plus equals. Okay. What plus equals does is plus equals is an instruction that we give to the compiler that essentially says we're going to do 3 things. The first thing I want to do is I want to take the value that's currently stored in X, I want to add 7 to it, and then I want to assign the result back to X. So like I said before, it's kind of like a little shortcut. It lets me take 3 actual separate steps and combine them into this one basic instruction. Okay, the same applies to all of the others. In fact, you could really say that each one of these is the same as its counterpart over here on the right. Now, again, keep in mind that we're not in math class anymore. You know, we're not in an algebra class or pre-algebra or calculus or anything like that. In a math class, this would be a false statement. There's no way that X could equal X plus 7. Or X could equal X minus 3. But we're not in a math class, we're in a Java class. The equal sign takes on a different meaning in Java. What this is saying is I want to evaluate whatever's on the right-hand side to the point that it's a single value, and then I'm going to take that value and I'm going to assign it to the variable that's on the left-hand side. So remember that our equal sign is the assignment operator. It's not, it doesn't have the same meaning or the same function that it has in a regular traditional math class. Okay, so for each one of these, X plus equals 7 is the same as saying take the value that's currently in X, add 7 to it, and then finally the last thing we're going to do is assign the value back to X. X divided by equals 5, we're going to take the value that's currently in X, we're going to divide it by 5, and once we find that result, we're going to assign it back to X. Okay, so remember our order of operations that we talked about back in topic 1.3. Okay, now I've got a little segment of code here. I've got a little program that I wrote where we're going to demonstrate our compound operators, and I'm going to pause. I'm going to ask you to pause the video here in just a second, and when I do, I want you to be the compiler. Okay, we're going to do a little exercise where you're going to trace code. So when you become the compiler, you are going to trace code on paper to determine the output. We do this exercise for a couple reasons. First off, you know, the most pressing thing we need to deal with is the fact that we're prepping for the AP exam, and the AP exam is a paper-based exam. There will be questions on there that require that you trace code on paper. But even beyond the AP exam, you know, when we're working with programs that others have written, there will always be a need for us to be able to trace through the code on paper to determine what the program does or to identify bugs. So tracing code on paper is a big part of what we as programmers do. So it's an exercise. It's something that needs practice. You know, we need to be able to practice going through and we develop a system for tracing code on paper. So what I'd like you to do, pause the video, trace the code on paper to determine what the output's going to be, and then after you've had a chance to do that, again, we're not doing this in your IDE. This is strictly a paper-based exercise. Once you've had a chance to do that, press play, and we'll continue, and we'll kind of break it down piece by piece. So go ahead and press pause, and when you're ready, press play, and we'll keep going. Okay, welcome back. Let's see how we did. So when we become the compiler, you know, on the side of my paper, I always leave a little space, or maybe I'll grab a separate piece of paper to trace this through. But when we become the compiler, we are literally going to do everything piece by piece that the compiler would do. We break this down and work through it line by line by line. So the first thing that happens is we declare a variable X, and then we initialize that variable X so it has a value of 6. Okay, now as we work through each line, the next line says that we're going to take the value of x, we're going to add 7 to it, and we're going to assign the value back to x. So the current value of x is 6. We add 7 to get 13. And then once we have that value, we assign it back to x. So we cross the 6 out. X now has a value of 13 after we've hit that statement. The next line, we're going to use minus equals. So we're going to take the value that's currently in x, we're going to subtract 3 to find the result of 10, and then we're going to assign the 10 back to x. So x is no longer 13, x now has a value of 10. We're going to use multiply equals. So we're going to take the current value in x, we're going to multiply it by 10 to get 100, and we're going to assign that result back to x. So x is no longer 10, x now has a value of 100. We'll use divided by equals or division equals. So we're going to take the current value of x, which is 100. We're going to divide by 5 to get 20, and we assign the 20 back to x. And then finally, we use modulus equals. So when we do 20 modulus 3, remember that we're looking for the remainder of a division problem. So if I do 20 divided by 3, 3 goes into 20 6 times to get 18. When I take 20 minus 18, we end up with 2 left over. So 20 modulus 3 would mean we have a remainder of 2. And I take that value of 2 and I assign the 2 back to x. So at this point, we've worked through all of this code. And by the time I finish that second to last line, the x modulus equals 3 line, x has a value of 2. And then the last thing we do is we display the value of x to the screen. So our value that gets displayed to the screen in this case by system.out is 2. Okay. That's our demo of the compound operators. So the main takeaways, the main things we want to take away from this video. Like I said, our overall learning objective is to continue to evaluate what is being stored in a variable as a result of an expression with an assignment statement. So these are examples of assignment statements. They're compound assignment statements, but they still do what the assignment operator does. They take a value that's on the right and they assign it to what's on the left. It's just they do a little bit more with it. So the compound assignment operators, plus equals, minus equals, and so on, can be used in place of the just generic equal sign assignment operator. All right, thank you for joining me today. It's been a pleasure to be here with you. Again, please continue to watch the videos that come after this one. If there's anything that you're feeling a little iffy on and maybe feel like you need some review, remember you can always go back and watch previous videos, but also continue to watch the videos that come after this one. I hope everybody has a great day, and I'll see you the next time.